We are going to finish yesterday's notes and then do our notes for today. It should go like boom, 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 and then we can do some of your homework. Okay? So, ready? Look at the first one. Okay, I want you to tell me what your units are for the function r of t. You can look in the table. Okay, so what are my units though for my y-axis? Okay, tons per month. And then what's on the x-axis for time? Okay, months. So listen, when we find an integral, remember that that's area. How do you find area of a rectangle? What do? Base times height. But what are your units for your base? We just labeled it. Months multiplied by, and then what are your units for height? Tons per month. What is going to happen if I multiply months times tons per month? It's just going to be tons. So remember that when you do an integral, if it's tons per month, when you integrate, you just get tons. Now, question. So tons per month. Okay, if I do an integral, I just get tons. What would I get if I took a derivative? Tons per month squared. Okay, so remember that when you take a derivative, you're increasing the denominator of power. But when you're doing an antiderivative, you'd be taking the bottom away. Does that make sense? Okay, so one more time. If you have tons per month, a derivative would be tons per month squared, but an antiderivative would just be tons. Okay, so let's do what our integral represents. Okay, our integral represents the number of tons, and then we have to go back and read the question to see what the tons are. So it says, the pollutants in the gas are removed by scrubbers. R of t represents the rate that scrubbers are removing pollutants in tons per month. So that means that I have the number of tons of pollutants removed by the scrubbers, and then over what interval of time? Look at your endpoints. Okay, over 0 to 6 months. Okay? But you would have to have units for everything. So when I integrate tons per month, I get tons. Tons of what? Tons of pollutants the scrubbers removed. Over what time? 0 to 6 months. Okay? Now we're going to do several of them. So when you've got that, turn to the next one. Reread what it was measuring. Am I good to turn it? No? Now good? Yes. I sure was. Okay, look at the next one. Okay, what are my units? It says it in the question. The rate of fuel consumption measured in what? Okay, so this is gallons per minute. And then what is time measured in? Time is measured in what? Minutes. Very good. Now remember, how do I find area? I multiply length times width. So if I do gallons per minute multiplied by minutes, what's going to happen? You get the number of gallons. Okay, now what are we talking about? Gallons of what? Gallons of fuel consumed by the plane over what time? 0 to 90 minutes. Make sense? So interpret the meaning. That would represent the gallons of fuel consumed by the plane over 0 to 90 minutes. You're basically saying like what the integral is giving you. So if I have gallons per whatever it is minutes, then when I integrate that, it's telling me a number of gallons over a certain number of minutes. Okay, go down one more. Car comes to a stop, number 3. Okay, what is my y-axis measured in? Look at your chart. Okay, this is in feet per second. What is my x-axis measured in? Okay, when I find area, I multiply y times x, okay, because it's base times height, then I'd get what? Number of feet. Now, in this case, we're talking about a car coming to a stop. So it would be the number of feet the car traveled over what time period? Over 0 to 9 seconds. Now, quick question. Okay, the number of feet the car traveled has a special name already. Starts with a D. Displacement. So remember that anytime you're integrating velocity, if you don't want to say the number of feet that the car traveled, you could just say displacement. You have a shortcut when you're integrating velocity. Anything else, though, you wouldn't say like the displacement of fuel. That would be weird. Okay? Yeah, sure. Let's finish. I think we have one more left in your notes. And then we can look at that. Okay, next one. R of T. Okay, is telling you the miles per hour that the boat was going. So, what is miles per hour multiplied by hours?
Miles.
Okay, it would be miles. So, you would say the integral represents total number of miles ship traveled over 7.5 to 9.5 hours. Now, you also could have said from 7:30 p.m. to 9:30 p.m. You could write that instead if you like that better. It doesn't matter, though. Okay, but you have to have units in two places, here and here. And if you don't put units in one part, you miss the whole interpretation. Okay? So, Wilson, what question off the homework did you say?
Number 8, where's the interpretation?
Okay, so let's go to number 8 on your homework. This is the homework you have already had. Homework 4. Number 8, okay? Good? Okay, so we're looking at number 8 off your homework. Okay, so this says I'm doing dollars per square meter. If I integrate dollars per meter, what am I going to get? Dollars per meter, I'm going to get dollars. And if you read it, it says, cold weather has caused Emmanuel to migrate south in search of a vacation house. He finds an island where it's $4 per square meter. Okay, then it says he's chosen a piece of land in the quadrant bounded by blah, blah, blah. Okay, so if I integrate dollars per meter, I'm going to get the total number of dollars that the vacation house
Still on that, bro? It's been a year.
is worth. Do you need this, honey? It's over on my little black shelf right there. Yep. Okay. Okay, then it asks you to do a left Riemann sum. Remember, you're going to have to make your own table. And you can just use your calculator to do that. Make your own table. Okay? So if I want to go from 0 to 6, okay, let's set up a little chart here. what would my intervals be if I need 3 of them from 0 to 6? How wide should they be? 2. Because think about it, I'm going to go 0 to 2, then what? 2 to 4, then 4 to 6. And then how will I get the values over here? I'll take my equation that they gave me, and I'll just plug it in. Make sense? And then from there, you'll do a left Riemann sum. Just follow. Now, how would you find the total value? You'll take how big it is and times it by 4. Yeah?
What do you mean how big?
You'll take your integral, and then it says it's $4 per square yard, so you'll just times it by 4. Because it says the price is $4. Okay. Yes?
Can you do 1B?
Sure. Let's get back to 1B. 1B. The midpoint. Okay. Oh, you messaged me about this. Sorry, I forgot to reply. Okay, so when it's a midpoint, you just skip 1 each time. So I'm going to go from 0 to 2. How wide is that? What's my delta x? 2. And then I'm going to multiply by the middle y value. Now, the exact middle of 0 and 2 is 1, but that's not in my chart. So I'm going to use the point they gave me, which would be 1.5, so I'm going to use 180. Okay, then my next jump, I'm going to go from 2 to 6.5. How wide is that? 4.5. And then what is my middle y value? 360. Does that make sense? So it doesn't have to be the exact midpoint. If the midpoint's not in the table, you use whatever point you skipped over as your middle value. Yes, ma'am? 2 to, no, it's from 2 to 4 to 6.5.
On part B, you wrote 2 times 180. I thought it would be 1.5.
Well, but you're using the y value at 1.5.
Okay.
Does that make sense? So remember, you're always doing a delta x times a y value. So I'm using the middle x, but I'm getting its y value. Does that make sense? Okay, so next one, I'm going from 6.5 to 9. How far is that? 2.5. And then what is the middle y value? 500. So it'd be 2.5 times 500. Okay, then last one from 9 to 10. What's my delta x? 1. And what's my middle y value? 605. Make sense? So it is not necessary for you to have equal subintervals. It's fine if they're different. Just skip 1 each time. Okay?
Yes.
Good. All right, so let's go to your notes. We're going to do one just little shortcut abbreviation, then we'll do your classwork just like we did yesterday. Okay? So what you are learning today is the last type of Riemann sum. Okay, and it's called a trapezoidal sum. Okay, we're going to start off exactly like yesterday. So, draw a graph, not geometric. Okay, so I'm just going to did we do like a quadratic yesterday? Like that or something, right? Okay, we're going to call that f of x. We're going to let a be here, b be here. Remember, my integral is this exact space between the function on top and the x-axis on the bottom. Okay, then you're going to split your area up into pieces, just like we did yesterday. So here's A, here's B. You're going to cut it in half. Then you're going to cut those halves in half. Got it? Okay, so long ago, Okay, what shape were they using to estimate the area? We did it yesterday. Rectangles, right? So they'd be like, I'm going to pick the left side and do a left. I'll do a right side. Then one little dweeb was like, what if we made a rectangle but we gave it a slanted top? That's already a shape. What shape is that? Trapezoid. Then we're going to take the next two dots. We're going to give that rectangle a slanty top. Boom, trapezoid. Then I'm going to connect these two with a slanty top. And these two with a slanty top. Now look at the error on that graph compared to the ones we did yesterday. Okay, this one has way smaller gaps that you're missing. Okay? So the other bonus when you're doing a trapezoidal sum is that you're not skipping any of the y values. Okay, reason why is when I do this first one, this is y1, y2, y3, y4, and y5. Watch when I add up the areas. Okay, I'm going to call this one trapezoid 1. When I do the area of trapezoid 1, how do you find the area of a trapezoid in general? Okay, base 1 plus base 2, half in the front times delta, times height. Ooh, erasable pen. Nikki's not even here to be happy about it. Okay, so what we're going to do is we're going to replace that with all of our Riemann sum stuff. Now, yeah, for like trapezoid, you know. So, base 1 and base 2 are here. So I'm going to call those y1 and y2. And then the height is here. What am I going to call that? We already did it yesterday. Delta x. So for my area 1, we'll put area equals. I'm going to do 1/2 y1 plus y2 times delta x. And that's the area of my very first trapezoid. Okay, now we're going to go on to the next trapezoid. This is trapezoid number 2. 1/2. What are trapezoid number 2's bases? y2 and y3. So y2 plus y3. Okay, next one. Okay, trapezoid number 3, A3. What are his two bases? y3 and y4. Oh, I forgot to put it. That's why. I'll fix it. Thank you. This one should have a delta x here. Don't forget that. Okay, then last one. We'll do A4 is the last trapezoid. Okay, it'd be plus 1/2 y4 plus y5 multiplied by delta x. Yes, there's not a point that gets skipped. Now, you will notice some points are in there twice. Why are they in there twice? Well, let's say y2, he's the bigger base for a1, and then he's the smaller base for a2. y3 is touching this trapezoid and that trapezoid. So some of them get counted twice, but nobody gets skipped. Make sense? Okay, so look at your notes for today. We're going to go kind of out of order. First one that we're going to do is number 4, about the gorilla. Okay, number 4, about the gorilla. Okay, it says, a gorilla, wearing a parachute for safety, okay, jumped off a building. His speed at various times is in the table below. Okay, then it says, part A, sketch a graph. We're going to skip that. Okay, part B. Must there have been a time when the gorilla's speed was 13? Yes or no? Okay, yes, when?
5 and 8.
Okay, between 5 and 8. What theorem says that? IVT. Okay, now, this is in your notes because it's on your quiz. Okay, so just let's review IVT. We haven't done it in a while. The first thing you have to state is that it's continuous. Very good. So I'm going to put speed is continuous. Okay, even if you're in the fastest car on earth, you can't immediately go whatever speed you want. You have to build up to it, even if it's really fast. Okay, the second thing is that you have to tell me the speed at two different points, and then the speed that you want in step 3 has to be between them. Now, you guys said from 5 to 8, so what's the speed at 5? 12. What's the speed at 8? 15, and then where is 13? Between. 13 is between 12 and 15. Therefore, can I guarantee it or no? Yes, IVT guarantees this. Okay, my gorilla cannot go from a speed of 12 to a speed of 15 without hitting 13 between them. Make sense? Okay, part B. Use a trapezoidal approximation to determine the total distance the gorilla traveled. Set up, do not solve. So I'm going to integrate the speed from 0 to 9 seconds. Okay, approximated by. And now we're going to go one trapezoid at a time. So for my first trapezoid, what are my two y values going to be? Base 1 is going to be 3, base 2 is going to be 7. So I'll do 1/2 3 plus 7, and then I need their delta x. Now, delta x is not the difference between these, it's the difference between these. So from 0 to 2, what's my delta x? 2. Plus. Okay, next one. What are my next two bases? 7 again, because remember, he gets counted twice, but now 7 is the first base, 11 is the second base, bless you. So 1/2 7 plus 11, and then how far apart are 7 and 11's x values? From 2 to 4, that's a delta x of 2 again. Plus. Next one. We're going from 11 again to 12. So I'll do 1/2 11 plus 12. And then I look at their x values and count how far apart their x values are. So if this is 4 and this is 5, how far apart are those? 1. So my delta x between 11 and 12 is the distance between 4 and 5, which is 1. Okay, plus, next one, I'm going 12 and 15 are my bases. Yeah, I had to kind of squeeze my 1/2 in there because I forgot about it. Okay, but then 12 and 15, what are their x values? 5 and 8, and the delta x there is 3. Plus, last one, 15 and 17 are my bases. And then how far apart are their x values? 1. Make sense? Now, again, set up, do not evaluate. Okay, same thing on your homework. Set the integrals up, okay, or the Riemann sums or trapezoidal sums, but don't actually click, click, click in your calculator. Waste of time. Don't bother. Okay, got it? Okay, let's do one like that off your homework 5. So, homework 5, we're gonna do number 2. Number 2, this is off of homework 5. Okay, so my first trapezoid. What are my first two y values for me to add up? So 0 to 90, a of t, approximated by. Okay, I need the y values. 20 and 30. So I'll do 1/2, 20 plus 30. And then I need to multiply by 2030's delta x. So look on the x side, 0 to 30, what's the difference there? 30 plus. Okay, what's my next set? My y values are 30 and 40, right? And then my delta x from 30 to 40 is 10. Does that make sense, what we're doing? So you're adding the y values, and then you're putting the half in the front and the delta x in the back. So what would my next one be? Okay, 40 plus what? 55. And then what's the difference from 40 to 50 in the x column? 10. Okay, you have 2 more left. Write them out and then we'll check them. Oh, and then this number that got hole punched, this was a 70 and this was a 90. You have 2 more trapezoids to add. So I did like the first 3, you have 2 more left. Okay, your next one should have been 1/2 55 plus 65, delta x of 20, because 50 to 70 is 20. And then 1/2 65 plus 70 with a delta x of 20. Make sense? Okay, now, quick question. If my units here are meters per second squared, what happens when I multiply meters per second squared by seconds? You get not just meters, but meters per second. Okay, so it can cross out one of the seconds off the bottom, but it can't cancel both of them. So I would say this integral would be the number of meters per second that, now what's the antiderivative of acceleration called? Velocity. So it would be the number of meters per second that velocity changed over 0 to 90 seconds. So when I integrate velocity, I get the change in position. When I integrate acceleration, I get the change in velocity. Make sense? Questions, anything so far? Okay. We have one more thing to cover that shortens this up a ton. So I want you to go back to your notes. Okay, let's pretend like all of your delta x's were the same. Remember, you had a shortcut for Riemann sums, you have a shortcut for this one as well. So let's pretend that you have all equal delta x subintervals. Okay? If you have all the exact same delta x, what can you GCF out of your formula? 2 things. That they all have a delta x, which we're pretending is the same. And then they also all have a 1/2. So your shortened version for this one, I'm going to write shortcut on it. Okay, half delta x, and then something else. Okay, when I add up my y values, okay, when you add up your y values, listen, I'm just going to tell you what they are, and then I'm going to write it down. I'd have, these are gone, y1 plus y2, these are gone, plus another y2 times a y3, plus, next one, another y3 and a y4, then another y4 and a y5. How many y2s did I have?
2.
How many y3s?
2.
How many y4s?
2.
Okay, then when I had y1 though, how many?
1.
What about 5?
1.
Only 1. So the very first one and the very last one, you're only going to have 1. But everyone in the middle counts twice as a base, so it will be in your short version twice. So this is what I mean by that. You're going to have y1 plus double y2, double y3, double y4, but then only one y5. So your very first term and your very last term don't get the 2, but everybody else does. And the reason why is because y2 is the second base for the first trapezoid, but then the first base for the first trapezoid. Okay? So, look at your notes. We're going to do one where they're the same. Huh?
Let's do a homework question.
We'll do one of each. We'll do one off here and then one on there. We're going to do number 2.
Is that homework question? Is that right?
We're going to do one off the notes, then one off the homework. Okay, so take a look at number 2. Okay, oil's leaking out. It's measured every 2 hours. This is in gallons per hour. When I integrate gallons per hour, what do I get? Gallons. Number of gallons that what? That leaked out of the tank from when? 0 to 12 hours. Very good. So it says, interpret the meaning. You would say, this is the number of gallons of oil leaked over 0 to 12 hours. Okay? And now let's do the shortcut. Now, real quick, look at your chart. How do I know that I can do the shortcut? 2, 4, 6, 8, 10, 12. Okay, so my delta x is 2 every time. That's when you can shortcut. So what you would do is 1/2 delta x. What's my delta x? 2. So really those can cancel out if you want. And then you're going to add the y values, but the first and the last one only count once. Everyone else counts twice. So I'll have 140 plus 2 38s, 2 36s, 2 30s, 2 26s, 2 18s, but only 1 8. So instead of having to do like 1,000 little trapezoids, you can shorten it up and do it like that. Okay? Alright. Last part on here, letter B, we haven't done yet, but we're going to cover it right now. R double prime, what feature of the graph does that tell you? Concavity, good. I know. Oh, do you know? It's supposed to be how. Okay. Concavity, if R double prime is less than 0, then that means what's my concavity? Concave down. So, I want you to draw a little picture of a graph that's concave down. We'll do like that. Okay, now, instead of doing a Riemann sum, we're doing trapezoidal sums. I'm only going to split it like into 2 pieces because we don't have to do 4 and it's easier with 2. Okay, so do 2 pieces. Okay, we'll say this is my real area. How is my trapezoid when I connect those pieces on a concave down graph? How is that area going to compare to the real area? It's similar, but it's going to be too small. So, if you have a concave down graph, okay, your trapezoid rule will underestimate the real area. Okay, if you have a concave down graph, every time your trapezoids are going to be too small. Every time. Okay, now there's a question on your homework that asks that, so let's go do that one. It's number 5. Oil leaking out of a barrel, number 5 off your homework. Okay, ready? First thing, long or short for my table? Number 5. Why can I do the short one for number 5? Because it's going by how much each time? 3. So my delta x is always 3. That means I get to do the short version. So I'm going to do 1/2 times 3. And then I'm going to add my bases. But remember, the first one and the last one count once. All the middle ones count twice. So I'll do 20 plus 2 31s, 2 28s, 2 24s, 2 22s, and then 1 21. You can only do the short version though when your delta x is always the same. So set up an integral expression, boom. Okay, we already did it. Now go to the second part. This time it tells me r double prime is greater than 0. What does that tell me about concavity? Then r of t is concave up. Draw a little concave up graph. Make it like that. Split it up into 2 pieces. You can do more, but you really only need 2. And then draw in where your trapezoids would go. My first trapezoid would be here. My second trapezoid will be here. How do the areas of my trapezoids compare to the real area that they're supposed to be estimating? They're a little bit too big, so they are over. So I'll put then trapezoids. Trapezoid rule is an over estimate for the actual area. Got it? Okay, then number 6, just to make sure you understand what you're doing there, 3 equal subintervals means that you would be dividing 12 by 3. How much is that? So you'd be going 0 to 4, 4 to 8, 8 to 12. So if it says 3 subintervals, that means you're dividing it into only 3 pieces. So from 0 to 4, how wide is that? 4. And then what is my left y value? From 0 to 4, left y value. 5's in the middle, it would have been 3. Okay, then I'm going to go to my next set of 4. Now I'm going from 4 to 8. My width is still the same, it's still 4 across, but which of these 3 is my left y value? 9. And then for my last set of 3, from 8 to 12, how wide is it? Still 4, that's why I was able to pull it out. But my left y value will be 6. So usually you do like, thank you.
Sorry.
Usually you do every single one, but if it says 3 pieces, you got to do 3 pieces. Good job. 4 whole minutes. Huh?
Wait, we just finished homework.
Okay, right Riemann sum, you'd take out, how big would your delta x be if it's 6 subintervals? You'd pull a 2 out. And then who do you skip if it's a right side, first or last? Skip the first, so 3 never gets counted. So it'd be 5 plus 9 plus 8 plus 6 plus 4 plus 5. And then trapezoidal rule is the one we just did. So you do your 1/2 delta x. What's your delta x every time? 2. And then you'd add up your bases. Remember, everybody counts on a trapezoid. So it'd be 3, double 5, double 9, double 8, double 6, double 4, and then a regular 5. Double 5, double 9, double 8, double 6, double 4, and then 1 5. And then someone in the other class was like, well, can I just make it 3 5s? Fine. That's the same if you want to. Okay, you can obviously change these. Or like if you had multiple 6s, you could combine it, but that's up to you. If you think that's easier, do it. If you don't, then don't. Yes? Sure. All right, good job. Oh,
It's okay.
average rate of change would be your AROC. So for average acceleration, you do AROC. So you do V of 30 minus V of 0 over 30 minus 0. Because remember, acceleration, if this is velocity, then acceleration's the slope.
This doesn't make sense to me.
Okay, so if they're telling you 3 equal subintervals, if I go 0 to...
Yeah, I know you're going to divide it 3, but I'm saying like the values on it.
Okay, so let's graph it. Let me stop.